Hello mathematicians, we're going to begin our study of log and exponential functions with a quick review of what we know already. And you might recall this definition earlier on, that the log of base a of a positive number x is the index when the number x is expressed as a power of the base a. Now what that means is something much simpler when you express it mathematically, and it's just that if we have y equals a to the x, then the log relationship says that log base a of y equals x. In other words, if we raise a to the x power, that gives us y. So if, for example, and we used this example previously, if we knew that 100 was 10 squared, then log base 10 of 100 is equal to 2. This raised to this power gives us this number. Now we also pointed out before that the log function and the exponential function are mutually inverse, so they undo the effect of each other and we get back to where we started. So if we take the log of an exponential or the exponential of a log, then they cancel each other out. So if we look at this in a little bit more detail, if we had y equals a to the x, if we took the log to base a of both sides, so we took the log base to base a of y and log to base a of a to the x, then log base a and the operation of a being raised to the x cancel each other out to just leave us with x, which is our relationship just here. And now if in turn we raise both sides with a as the base, so a raised to the log base a of y and a raised to the x, again a and log a cancel each other out, so we just return to y equals a to the x, which is our relationship here. So this is that series of equations or operations just spelt out a little bit more explicitly. You could also go to your calculator and show this in operation as well. So let's put a 2 into the calculator. So if I press 2 and equals, so that I've got the 2 sitting there. Now I'm going to, and it doesn't matter what order I do these operations in, but let's suppose that I raise 10 to the power of 2. So that will be second 10 to the x. I want 10 raised to the power of 2, which happened to be our answer there. 10 to the 2, as we saw up above, is 100. And if I took log to base 10 of that answer, the 100, then I get back to my 2. So the operations cancel each other out when they're done in succession. Now because of that, if you graph the log function and the exponential function, given that they're mutually inverse operations, we see that their graphs are reflections of each other in the line y equals x. It's important to know the features of the log function graph and the results of transforming it, and this again should not be new material. So the log graph looks like this, and this particular log graph is a graph of log base 2. So all the powers when 2 is raised to something. So if, for example, we looked at when x equals 4, then 2 raised to what power gives me 4? And the answer is 2. 2 raised to the power of 2 gives me 4. 2 raised to what power gives me 8? I come up here and the answer is 3. So that's our construction of that graph there. You'll notice that regardless of the base of the graph, it will always pass through this point here, because any base raised to the 0th power will, raised to the 0th power will give us 1. Now if we look at our log curve, we can see that the domain of log base 2, and in fact the domain of all log curves, is x greater than 0. We can't take the log of a negative number. The range of log base 2, and again all log curves, is all y values. So this curve runs on to negative infinity, and if we go far enough out here it goes up to positive infinity. We also need to think about transforming it. So if we had a curve f of x, and we took f of x minus 1, so in this case log base 2 of x minus 1, we know that shifts the whole curve to the right by one place. Likewise, f of x plus 1, so log base 2 of x plus 1 shifts the curve to the left by one place. And f of x with a 1 added to it is going to shift the curve up by 1. So that's log base 2 of x plus 1 added onto it. Now here are a couple of other variations. So again, our green curve is log base 2 of x. So we can see that minus log base 2 of x is a reflection in the x-axis, and log base 2 of minus x is a reflection in the y-axis. However, back to our curve, back to our fact that the log curve and the exponential curve are reflections of each other in this line. This line, of course, is y equals x. And you'll remember when we used our calculator before, we said that something like when x equals 4, log base 2 of 4, we come up here, that's going to give us a value of 2. If we then operate on 2 with our other function, 2 to the x, then 2 raised to the second power gives us 4. It takes us back where we started from. So they cancel each other out, and it doesn't matter which graph you start with. Now, this y equals x is also just 2 raised to the log base 2 of x. Or if you like, it's log base 2 of 2 to the x. They're both going to give you y equals x when they cancel each other out. So that's why they reflect in the axis there. Now, these should all be known from previously: the product law, the quotient law, and the power law, and we've used those since then. And as a consequence of those laws and what we already know, we should be fairly comfortable with these relationships. So a to the 0 equals 1. We know this is a to the minus 1, so a to the minus 1 is 1 on a. A to the 1 is a. Coming back here to our case of log base a of 1 on x being log base a of x to the minus 1, if we use the power rule, we can bring the negative out the front. And similarly, log base a of square root of a is a half. So let's have a look at a couple of examples. So we'll start with b here because it's the easier of the two. So this is saying that 125 raised to what power gives me 25. Now the simplest way to analyse these through our knowledge of powers of 5 is to say, well, what we've got on the left hand side is 5 squared, and what we've got on the right hand side is 5 cubed raised to that power, so it's really 5 to the 3 times the question mark. So therefore 3 times the question mark has to equal 2, so the question mark is 2 over 3. This one here, our brain should be saying simultaneous equations because we've got 2 pieces of information. So what have we got? 2 raised to what power gives us 32? Well, we know that that is 5, so 2xy minus y must equal 5. And similarly, 2 raised to what power gives us 128? Well, that is 7. So 4x plus y equals 7, and away we go from there. Very quickly, if we added those two, we'll get 6x equals 12, so x equals 2. And if x equals 2, then we've got 4 minus y equals 5, so y equals minus 1. So have a go at these out of 12a, but before that you might like to get your thoughts in order by putting down a rough summary so that you can recall quickly what are the key facts about logs and their relationship to exponents that you need to be aware of.